Hey Knights, welcome to tonight's video in our Data and Statistics unit. This section of notes is going to be called Range, Distribution, and Stem and Leaf Plots. So we're going to learn two more statistics vocabulary words and then one more type of graph that we can make with our data. Our first scenario, the Yes Prep Northbrook track team was practicing for the 100-meter dash. They recorded their times in seconds below, and then we have a list of times. We are going to put these times on this number line. First things first, I need a title for my graph. I'm going to label it Practice Times. Now I need to label my number line down there. I see that the smallest number that I need to plot is 12, and the highest number I need to plot is 20, so I'm going to start at 12 down here. 13, 14, 15. Then I am going to put my x's. My x is going to be equal to only one person's time, so I'm going to put that in the corner. I have a 13, 15, 14, 13, 15, 15, 13, 12, 14, 17, 16, 13, 18, and 20. I've plotted all my times. My minimum, we learned, is the smallest piece of data that we have. The smallest piece of data that I have here is 12, so my minimum is 12. The maximum amount of data that I have is 20. My mode, the thing that shows up the most, is 13. I'm going to put that right there. It shows up 4 times. My range, that is a new word that we have not yet talked about. So let's read key point number 1 so that we can fill in that box. Key point number 1 says the range, or spread, we can say it either way, describes how spread out your data points are in a data set. It is the distance between the maximum and the minimum. So my range is going to be how spread out my data is. So from my first data point to my last data point, how spread out are these two things? Well, to get from 12 all the way to 20, I need to go 1, 2, 3, 4, 5, 6, 7, 8. So my range here is going to be 8 because the distance between them is 8. All right, my distribution, that's another word we're not familiar with yet. So let's go ahead and look at key point number 2 so we can learn about distribution. Distribution is the way which the data are distributed. There are 3 common types of distribution: symmetric, asymmetric, skewed right, that just means not symmetrical, skewed right, asymmetric, skewed left. So I noticed that my symmetric data kind of goes in a nice arch. It's almost the same on both sides. My skewed right data is high on one side, and then as we move right, gets lower. My asymmetric skewed left data is high on the left side, and then gets lower as I move, high on the right side, and then gets smaller as I move to the left. I'm going to go ahead and look at the data that I have, and I'm going to actually draw a little arch around my data so I can take a better look at this shape. So I notice that it's high over there on the left side, and then as I move right, it gets smaller. I'm going to look at my examples down here and see which one that looks like. That looks most like this graph right here. So I'm going to say that the distribution of my data is skewed right. Skewed right. Can I write that right in here? Skewed right. All right, I'm going to go ahead and move on. The Yes Prep Northbrook track team competed with 5 other schools at a district track meet. All the times are recorded in seconds below. That is a lot of times. Would it make sense to organize this data using a dot plot or a line plot, the things that we've been doing? Why or why not? So go ahead and pause this video and write down, would it make sense to put all of these points on a dot plot? Why or why not? Pause the video. All right, welcome back. There's no right answer. You could say whether it makes sense or not. I would say no, it does not make sense for a couple of reasons. I would say reason number 1 is that there are too many points. That would be a lot of X's to draw, and that's just too many. There are too many points. The second reason that I would list for why that does not make sense is that the range is too big. So I put range too big. I would need to draw a number line that went from, the smallest point I see there is 9. That went from 9 all the way up to 32. That would be a really big number line. I think the range is too big to put this successfully on a dot plot. So we're going to learn about a different type of graph that works better in this situation. Go ahead and take a look at this graph that we see. This graph here is called a stem and leaf plot. On one side here we have our stem, and on the other side we have our leaves. And it is listing this exact data that we saw up here. All of those track times for the track meet with the 5 other schools. The first thing I should do is underline, box, circle, whatever, the title, so I know what it's talking about. And I see a key down here, so I'm going to put a box around it so I know to pay attention. That key is telling me that when 2 is my stem and 3 is my leaf, when I have 2 as my stem and 3 as my leaf, that equals 23 seconds. That means 23. So using that information, what is the minimum time that I see on this stem and leaf plot? I would say the minimum amount of time I see is 8 seconds. So I'm going to put an 8 here. And the maximum amount of time I see is 32. The mode, the thing I see showing up the most, are all of these 5s here and all of the 8s. Because 1 is the stem for those, I know that that is 15 and 18. I'm going to take a second to notice a couple things about this stem and leaf plot. I'm noticing right now that my leaves are in order from least to greatest. I'm also noticing that there is a cluster of data around the number 1. You learned about cluster in yesterday's video. There's a cluster of data at number 1. The next thing it's asking me for here is the spread. If we look back at key point number 1, up here, we know that range and spread are the same thing. So it's just asking me for the range. The distance between my minimum and my maximum. The distance between my minimum and my maximum is 24. And the distribution. To see the distribution on this type of graph, you can just turn it sideways and draw the same shape above. I'm noticing that on the left here, it's higher, and then as we move right, it gets smaller. The type of distribution that is called is skewed right. So I'm going to write that in my distribution box. Skewed right. There's some questions there underneath. I want you to go ahead and pause the video and answer those now. Welcome back. The first question is, how many seconds does 3 for the stem and 0 for the leaf represent? I know because of my key that represents 30 seconds. The next question is, how many times were recorded at the track meet? I can just count all of my leaves. So this first one is 8. So there's 1 time, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, I counted all of my leaves. I'm not going to count my stems because that's just the tens place of my leaves. That's not a separate data point. So the amount of times that were recorded at the track meet is 38 times. There's 38 pieces of data there. How many runners took 15 seconds to run the 100-meter dash? Well, to find 15 seconds, I need to have a 1 in the ones place and a 1 in the tens place and a 5 in the ones place. I see 4 of those there. So 4 runners is my answer here. 4 runners. Let's go ahead and take a look at our key point number 3. Stem and leaf plots are a type of graph used to organize large data sets. Stem and leaf plots represent numerical data. So we remember numerical data is represented in numbers. Key point number 4. Side-by-side stem and leaf plots are used to compare data sets that are related to one another. So a side-by-side stem and leaf plot looks like this. So if you notice, this part of my stem and leaf plot is exactly the same as the one that was up there. But now we have some more leaves on this side. Our stems are the same. There they are. We just have leaves now on both sides of our stem and leaf plot. Just take a look at that stem and leaf plot and try your best to answer these questions. Go ahead and pause the video and do your best to answer them. Welcome back. Let's answer these together. What do the leaves on the left represent? This is the left over here. The leaves on the left represent the practice times. For that track meet, I'm sure you all circled or underlined the title and the key so that you could understand that graph when you were answering those questions. The leaves on the left represent practice times. What do I notice about the order of the numbers on the left and right? Well, I notice that starting from my stem and then moving outward into the leaves, it goes from greatest to least. So going this way, outward from my stem, it goes from least to greatest. And then going outward from my stem this way, it goes from least to greatest. So I'm going to write that as the leaves go out from the stem. From least to greatest. From smallest to biggest. How many runners took 13 seconds to run the 100-meter dash during practice. All right, so I need to find all the 13-second data points on the side where it says practice. First, I'm going to look for my stem that has a 1 because the key tells me that the stem is what gives me the tens place of my number, and the leaf gives me the ones place. So I'm going to look for where my tens place is a 1. That's right here. And then on my practice time, I'm going to look for all of the leaves that are a 3 to make 13. I see 4 of them. So my answer here is going to be 4 runners. Last question, how many more runners took 18 seconds at the meet than during practice? Well, during the meet, let's see, there's 1, 2, 3, 4 runners that took 18 seconds. Put a 4 down there. And during practice, I only see 1 runner took 18 seconds. To find how many more, I can just take my 4, subtract 1, and I'm going to get the answer of 3 more. Below this, there is some data in a blank stem and leaf plot and some questions. You are going to use this data that you see here, which is the age of grandparents, to create a stem and leaf plot below. Then you're going to fill in these boxes and you're going to answer these 2 questions. I'm going to get you started with your title and your key in 1 stem and leaf, and then you're going to do the rest on your own. So my title, I see that it's the age of grandparents, so I'm going to write that. The age of grandparents. I see that all the ages up here are 2 digits. So I'm going to have that tens place be my leaf, like the 8, and the ones place, or sorry, the tens place be my stem, and the ones place be my leaf. So 8 as the stem, 1 as the leaf would be equal to 81 years. For my stems, I need to look at all of those tens place things. I see the smallest tens place thing that I have is a 5, and the biggest is a 9. So I can go ahead and fill this in. 6, 7, 8. Now I need to fill this in from smallest to biggest, from least to greatest. The youngest age I see is 50, so I'm going to put a 0 here. The next smallest I see is 57. I can put a 7 here. I'm done with my 50s, moving on to my 60s. You're going to fill in the rest of this plot on your own at home. You're going to fill in all of these boxes, and then you're going to answer these 2 questions, and we are going to look over them tomorrow in class. See you.